Well, here we go. Simultaneous equations with three variables. This is probably one of the trickiest things that we've done so far. These problems take up a lot of room, so I'm going to start on a fresh page here. So the rule for simultaneous equations, because you can really have as many variables as you want. If you really want to take forever solving problems, you can have 5 variables, as many as you like. But for every variable, you need you need at least the same number of equations as you have variables. Otherwise, it's not solvable. So if we have 3 variables, we need 3 separate equations to start with. And here is why. Okay, so how do we approach this? Well, let's start by just picking 2 equations and forget the third one. Let's pick the first and the second one here. Now, of these 2 equations, which of the variables can we easily get to be the same? Well, that would be the x's. We just need to multiply the first equation by 2 to get 2x in both. So this first equation, if we multiply by 2, will become 2x plus 4y minus 6z equals -6. Now let's bring down the second equation just so we have them next to each other. Now how can we eliminate the 2x? Well, we're going to subtract the bottom equation from the top equation. So 2x minus 2x is nothing. 4y minus -5y is 9y. -6z minus 4z is -10z. And -6 minus 13 is -19. So here is one equation with 2 variables. Now what we need to do is get a second equation with 2 variables. And the variables need to be y and z, which means we once again have to come up with an equation that eliminates x. So now let's pick another set of 2 equations here. We already did the first and the second. Let's try the first and the third now. So we need to eliminate x once again so that we're left with y and z. So if we look at the x's here, we have x and 5x. So in order to have 5x in both, we're going to this time be multiplying the first equation by 5. So we will have 5x plus 10y minus 15z equals -15. Now bring down the third equation here. And now we're going to subtract 5x minus 5x is 0, 10y minus 6y minus 4y is 6y, -15z minus -z is -14z, and -15 minus 5 is -20. Now what we're left with is what we did in the last video. We have 2 equations with 2 variables. So we now need to eliminate either y or z. So we can pick 14 and 10 or 6 and 9. 6 and 9 seems like easier numbers to find a lowest common multiple, and that will be 18. So in order to get 18y, this equation will be multiplied by 2, and this equation will be multiplied by 3. So we will get, from this one, we'll get 18y minus 20z equals -38. And from this one, we'll get 18y minus 42z equals -60. And now we can just subtract to eliminate 18y. So 18y minus 18y goes away. -20z minus -42z is positive 22z. And -38 minus -60 is 22. So z equals 1. Okay, So now we have solved for one variable. That took the most work. Now we can easily find y using any equation with both y and z in it. Let's just pick this one right here. 9y minus 10z equals negative 19. So 9 times y minus 10 times z of 1 equals negative 19. Now we can solve for y and get y equals negative 1. And now, finding x, we want to choose any equation with all three variables and substitute both y and z into that. So let's pick the very first one here. We'll have x plus 2 times y of negative 1 minus 3 times z of 1 equals negative 3. So this will be x minus 2 minus 3 equals negative 3. So x will equal negative 3 plus 2 is 2. Now to write our solution, it's going to be x comma y comma z. It's a 3-variable ordered pair. So let's see, we can squeeze it down here. We have x is 2, y is negative 1, z is 1. And that is the solution to this simultaneous equation of 3 variables. X is 2, y is negative 1, z is 1. If you were to plug all of those back into all 3 of these equations, they would all be true. So really the hardest thing about this is that it just takes a long time to get the solution. But it's really just the same steps as what we've been doing. Okay, let's try another one like that before we move on to something a little more confusing. Alright, so this is going to be the same thing. So just to mix it up a little bit, let's try to get the y's to be the same coefficient this time. It's probably easier to do x's again since we already have a 1 here. 1 is usually means it's easier to use that variable. But to make this a little different, let's look at the first 2 equations. 4y and 3y. Remember, don't worry about the negative because we can always add instead of subtracting. So we need to get both of these equations to have 12y. So we're going to multiply this first one by 3 and the second one by 4. And so we'll get the first one is 15x minus 12y plus 12z equals 54. The second one is negative 4x plus 12y minus 8z equals 0. Now to eliminate the y's, we can just add. Negative 12y plus 12y will go away. So we're adding, we'll have 15x plus negative 4x is 11x, and 12z plus negative 8z is plus 4z. 54 plus 0 is 54. So there is one equation with x and z. Now we need to find another one. So this time, let's just pick, we can either pick the first and the third or the second and the third. Let's just choose the second and the third. So we have 3y and negative 2y. Remember, we have to use the same variable again to eliminate so that we end up with another equation that only has x and z. So we need to make the y's the same coefficient. So that will be 6y, which means we'll multiply the second equation here by 2, and we'll multiply the third one by 3. So if we do that, we'll get the first one times 2 is negative 2x plus 6y minus 4z equals 0. And the third one times 3 is 12x minus 6y plus 21z equals 9. Now we once again add to eliminate the y's, so negative 2 plus 12 is 10x, negative 4 plus 21 is 17z, and 0 plus 9 is 9. Now, we have two equations with both x and z right here. So now we're just doing a simultaneous equation with two variables. So we can either pick x's or z's. Either way, it's going to be kind of high because for 17, 11, and 10, there aren't really any lowest common multiples. So let's just pick x. The LCM of 10 and 11 is 110. So we'll need to multiply this one by 10. And we'll need to multiply this one by 11. So this one times 10, that's pretty easy. Just put a 0 in front of everything. And this one times 11, we're going to have 110x. 17 times 11 is 187. 9 times 11 is 99. When we subtract, we'll subtract 110x minus 110x is 0. 40z minus 187z is negative 147z. And 540 minus 91 is 441. Now you have very high numbers for dividing here, but don't be intimidated because usually you're going to end up with a whole number. So let's look at this. 147 is very close to 150. 440 is very close to 450. So we're really just doing 450 divided by negative 150, which is negative 3. So that's the hardest part, is getting the first variable. Once we do that, we're just substituting back in. So now that we know z equals negative 3, pick an equation with z and one other variable. So let's look at this equation right here. We have z and x, so we can use that. So now we'll be solving for x. We'll have 10x plus 17 times z of negative 3 equals 9. So 10x minus 51 equals 9. 10x equals 60, x equals 6. And now we just need y. So let's go back up here and pick an equation, any of these equations. They all have all three variables, so we can use any of them. So let's pick the second one here. Negative x, careful here, negative times x of 6 plus 3 times y, we don't know what y is, minus 2 times z of negative 3 equals 0. So this will be negative 6 plus 3y plus 6 equals 0. 3y, we can see negative 6 plus 6 is 0, so that disappears. 3y equals 0, y equals 0. And here is our solution. X of 6, y of 0, z of negative 3. Alright, now let's take a look at one more. X plus y plus z equals 2. 3x plus 3y plus 3z equals 14. And x minus 2y plus z equals 4. So, with this doesn't look too difficult. All the numbers are pretty low, so we can pick any of the variables that we want to get the same. So, you'll immediately notice something a little strange. In the first one, we have 1x, 1y, 1z, 3x, 3y, 3z. So if we multiply the first equation by 3, we're going to get 3x plus 3y plus 3z equals 6. Now we have the exact same number of both variables, but equal to a different number. 3x plus 3y plus 3z is 14 here. 3x plus 3y plus 3z is 6 here. And that is impossible. So there is no solution here. If you ever have the exact same thing equal to two separate numbers in the same problem, that is impossible. There is no solution. Okay, we're going to stop there, but we are not done with simultaneous equations in three variables. Next time we're going to see what happens when we have infinite solutions, because there are ways to sort of half solve that, and it's actually pretty interesting. So